Question 1. Considering the evidence, Maria manages an OSI environment where multiple teams require isolated access to resources in different projects. She wants to logically separate resources but allow centralized billing and governance. What is the best OSI feature for Maria to use? A. Compartments. B. Dynamic groups. C. Network security groups. D. Resource manager. Answer. Correct answer. A. Explanation. Compartments in OSI serve as logical containers to isolate and organize cloud resources for access control, billing, and governance. They enable administrators to apply policies specific to teams or projects, ensuring isolation without creating separate OSI tenants. Dynamic groups automate permission assignments for compute instances, but do not provide logical resource separation. Network secure. Groups control network traffic, not resource grouping. Resource Manager automates infrastructure provisioning but doesn't segment resources for access control. Thus, compartments are fundamental for organizing and securing resources while maintaining centralized management. Question 2. From the perspective of network security, Alex configures a virtual cloud network with multiple subnets and wants to allow selective traffic only between specific groups of instances within the same subnet. What OSI feature should Alex use to enforce fine-grained, stateful access control? A. Security lists. B. Network security groups and NDS. C. Route tables. D. Internet gateway. Answer. Correct answer. D. Explanation. Internet gateway provides outbound internet access to the vCEN and does not control internal subnet traffic or instance-to-instance communication. Security lists apply at the subnet level, affecting all instances within, lacking granularity. Route tables direct traffic between subnets or gateways but don't filter traffic. Network security groups SDS provide fine-grained, stateful filtering for group instances, allowing selective traffic control between defined sets of compute instances, making them ideal for internal segmentation and security within subnets. Question 3. Given the circumstances, David plans to automate the provisioning of a set of OSI resources with a defined configuration that can be version controlled and easily repeated across environments. Which OSI service best supports this infrastructure as code approach? A. OSI CLI. B. Resource Manager. C. Ansible integration. D. Shell scripting. Answer. Correct answer. C. Explanation. OSI Resource Manager is Oracle's managed service for infrastructure provisioning using Terraform, supporting infrastructure as code with version control and repeatable deployments. OSI CLI and Shell scripting offer command line control and automation but lack built-in IAC orchestration or state management. Ansible integration is for configuration management, but OSI Resource Manager with Terraform is the recommended tool for declarative infrastructure provisioning in OSI, ensuring reproducible and auditable environment setups. Question 4. During the process of troubleshooting, Emma notices that her OSI compute instance is not responding to API requests, but the instance is running normally. What is the most appropriate OSI feature she should use to gain out-of-band access for diagnostics? A. Console connections. B. SSH key rotation. C. OSI monitoring service. D. Alarms and notifications. Answer. Correct answer. C. Explanation. OSI monitoring service collects metrics and visualizes resource performance but doesn't provide direct access to instances. SSH key rotation relates to security credential updates. Alarms and notifications alert based on thresholds but do not provide access. Console connections allow out-of-band direct console access to the instance's serial console, enabling troubleshooting when normal network connectivity or API access is unavailable, making it the most appropriate tool for diagnostics in this scenario. Question 5. In the context of cost management, John needs to ensure his team does not exceed the allocated budget for compute and storage resources. What OSI feature should he implement to proactively monitor and control spending? A. Budgets and budget alerts. B. Tagging. C. Compartment quitters. D. Cost analysis dashboard. Answer. Correct answer. B. Explanation. Budgets and budget alerts allow setting monetary limits and notifying when thresholds are exceeded but do not enforce limits. Tagging helps classify resources for detailed cost tracking and allocation, but does not itself monitor spending. Compartment quotas set hard resource limits, preventing over-provisioning, directly controlling resource consumption. The cost analysis dashboard provides spending insights, but enforcement. Thus, compartment quotas are best for proactively limiting resource usage to prevent budget overruns, while budgets and tagging support monitoring and reporting. Question 6. Illustrated by OSI best practices, Samantha wants to ensure that all data written to a block volume is encrypted at rest by default without requiring manual intervention. Which OSI feature should she enable? A. Vault with customer managed keys, CMKS. B. Default encryption in object storage. C. Service gateway encryption. D. Compartment policies. Answer. Correct answer, D. Explanation. Vault with CMKS manages encryption keys but requires explicit configuration for volumes. Default encryption in object storage is for object data, not block volumes. Service Gateway allows private access to OSI services unrelated to encryption. Compartment policies can enforce security standards by restricting unencrypted resource creation, ensuring encryption at rest by default with manual action on each volume. Implementing policies to mandate encryption compliance is the best practice to enforce default encryption. Question 7. According to recent studies, Raj is designing a multi-tier web application on OSI wants to distribute traffic across several compute instances to maximize availability and performance. What OSI components should Raj deploy? A. Load balancer. B. DNS steering policy. C. Dynamic routing gateway. D. Network security group. Answer. Correct answer, A. Explanation. A load balancer distributes incoming application traffic across multiple compute instances, improving availability and performance. DNS tiering policies manage domain name traffic routing for failover or geographic distribution, but don't balance traffic at the instance level. Dynamic routing gateway manages connectivity between VCN and on-premises networks unrelated to load balancing. Security groups control security rules, not traffic distribution. Therefore, load balancer is essential for efficiently distributing traffic among backend instances. Question 8. The fundamental question is, when considering instance principals for OAPI authentication, what is the primary advantage over storing API keys directly on a compute instance? A. Instance principals require manual key rotation. B. They allow instances to make API calls without managing credentials. C. They restrict access to only a single compartment. D. They increase network latency for API calls. Answer. Correct answer, B. Explanation. Instance principals enable OSI compute instances to authenticate and make API calls without storing long-lived credentials, reducing risk of credential exposure and eliminating manual key management. They do not inherently restrict access to a single compartment. Permissions are governed by EM policies attached to the dynamic group. Instance principals improve security and operational simplicity. Manual key rotation is required for stored API keys, not instance principals. No latency increase is introduced by using instance principals. Question 9. Throughout the course of monitoring, Helen notices increasing latency in her OSI database instance queries. Which OSI feature should she utilize to diagnose the root cause of this performance degradation? A. OSI monitoring service with metric query language MUL. B. OSI Vault for encryption key rotation. C. OSI notifications for alert delivery. D. OSI load balancer health checks. Answer. Correct answer, D. Explanation. OSI load balancer health checks monitor the health of backend compute instances but do not analyze database query performance or latency. OSI Vault manages encryption keys unrelated to performance diagnostics. OSI notifications handle alerting but don't provide diagnostic data. OSI monitoring service with MUL enables detailed collection, filtering, and visualization of performance metrics, including database, latency, resource utilization, and query execution statistics. This makes OSI monitoring with MUL the best tool for root cause analysis of performance issues. Question 10. Based on the information, Michael wants to ensure that backups of critical OSI block volumes are replicated automatically across different regions to satisfy disaster recovery requirements. Which OSI feature should he use? A. Cross-region data copy. B. Backup vault replication. C. Object lifecycle management. D. Compartment quotas. Answer. Correct answer. A. Explanation. Cross-region data copy enables replication of block volume backups between OSI regions for disaster recovery, ensuring data availability in case of regional failure. Backup vaults store backups but don't replicate them automatically. Object lifecycle management automates transitioning of objects between storage tiers, not cross-region replication of block storage. Compartment quotas control resource limits and do not manage backup replication. Therefore, cross-region data copy is essential for multi-region disaster recovery strategies. Question 11. In a modern context of OSI security, Preo wants to grant permissions to a set of compute instances that dynamically change based on their metadata without manually updating policies. What OSI feature should she use to automate this process? A. Dynamic groups. B. Compartments. C. Network security groups. D. Service gateway. Answer. Correct answer. C. Explanation. Dynamic groups allow administrators to define rules based on instance metadata to automatically assign permissions without manual policy changes, simplifying permission management for changing instance populations. Compartments organize resources but don't automate permission assignment. Network security groups are for network traffic control, not IAM permissions. Service gateways enable private access. OSI services and do not manage identities or access permissions. Dynamic groups are fundamental OSI IAM feature for scalable automated permission assignments. Question 12. Taking into account the evidence, John observes intermittent connectivity failures between his on-premises data center and OSI. He suspects issues in the private connectivity link. What OSI service should John check and possibly reconfigure to improve this connection? A. Internet gateway. B. Fast Connect. C. NAT gateway. D. Service gateway. Answer. Correct answer. D. Explanation. Fast Connect provides private, dedicated connectivity between on-premises and OSI, crucial for low latency and consistent network performance. Internet Gateway facilitates public internet access, irrelevant for private connections. NAT Gateway allows outbound traffic from private subnets to the internet, not private links. Service Gateway enables private access to OSI public services, but does not provide private links to on-premises. Therefore, Fast Connect is the service to investigate and optimize for private connectivity stability. Question 13. When evaluating the merits of OSI object storage lifecycle policies, Sarah wants to automatically archive data that hasn't been accessed for a long time to reduce storage costs. Which lifecycle action should she implement? A. Transition objects to archive storage. B. Delete objects after a set period. C. Replicate objects across regions. D. Enable versioning for objects. Answer. Correct answer. A. Explanation. Lifecycle policies can automatically transition objects from standard object storage to low-cost archive storage based on criteria such as last access time, which helps optimize storage costs without deleting data. Deleting objects permanently removes data, not archiving. Replication increases availability but does not reduce costs through tiering. Versioning maintains object history but does not up or reduce storage costs. Transitioning to archive storage balances cost efficiency with data retention. Question 14. Given the circumstances, Michael must troubleshoot why his OSI compute instance is unable to initiate API calls to other OSI services despite having appropriate IAM policies. What is the best practice he should verify first? A. Confirm that the instance is part of a dynamic group with the correct policies. B. Ensure the instance's compartment has public internet access enabled. C. Rotate the API key stored on the instance regularly. D. Verify that the instance has an assigned public IP address. Answer. Correct answer. B. Explanation. Public Internet access is not mandatory if the instance uses instance principals or service gateway for private access to OSI services. Correct IAM policies and dynamic group membership are required for permissions, but if the network path is blocked, API calls will fail. Rotating API keys is irrelevant if instance principals are used. Public IP addresses facilitate internet communication but are necessary with private connectivity. Verifying network connectivity, public or private, is crucial to successful API calls. Question 15. Within the framework of OSI monitoring, David wants to trigger an alert where CPU is on. A compute instance exceeds 80% for more than 5 minutes. Which OSI feature should he configure? A. Alarms and notifications. B. OSI Vault. C. Load balancer health checks. D. Metric query language ML. Answer. Correct answer. A. Explanation. Alarms allow setting thresholds on metrics like CPU edge and send notifications when conditions are met. OSI Vault manages encryption keys unrelated to monitoring. Load balancer health checks monitor backend instance availability, not resource metrics. MUL is the query language for retrieving and analyzing metrics but does not trigger alerts by itself. Therefore, alarms and notifications are essential for proactive performance monitoring and alerting. Question 16. While examining OSI network design, Sarah is tasked with controlling outbound internet traffic for her VCN while still allowing inbound responses. What OSI networking component should she use? A. NAT gateway. B. Internet gateway. C. Dynamic routing gateway. D. Service gateway. Answer. Correct answer. C. Explanation. NAT gateway enables instances in private subnets to initiate outbound internet connections while blocking inbound internet-initiated traffic suitable for controlled egress. Internet gateway allows unrestricted inbound and outbound internet access. Dynamic routing gateway connects VCNs with on-premises networks but doesn't manage internet traffic control. Service gateway enables private access to Oracle services without internet exposure. NAT gateway is the correct component to manage controlled outbound internet traffic securely. Question 17. Based on the information, Raj is implementing an automated configuration management system that must integrate seamlessly with OSI to apply stateful changes and ensure compliance. Which tool is most appropriate for Raj to use? A. Ansible integration. B. OSI CLI. C. Terraform via Resource Manager. D. Shell scripting. Answer. Correct answer. D. Explanation. Ansible is a configuration management tool designed to manage stateful changes and compliance through playbooks and modules, offering seamless OSI integration and idempotency. OSI CLI and Shell scripting provide basic scripting and automation but lack advanced configuration management features. Terraform, through Resource Manager, focuses on infrastructure provisioning IAC rather than stateful configuration management. Therefore, Ansible integration is the best fit for automated, stateful configuration enforcement in OSI environments. Question 18. The primary reason for using OSI Vault when managing secrets in a cloud-native application is to A. Store API keys securely and enable controlled access. B. Automate compute instance scaling based on load. C. Provision network resources dynamically. D. Manage database backup schedules. Answer. Correct answer. A. Explanation. OSI Vault is designed to securely store and manage encryption keys and secrets, such as API keys, providing fine-grained access control, auditing, and secure retrieval, crucial for cloud-native security best practices. It does not handle compute scaling, network provisioning, or backup management. Its role is focused on secrets management and key lifecycle operations, enhancing security posture compliant. Question 19. When analyzing OSI load balancer configuration, what must Allison verify to ensure proper distribution of traffic to backend instances in multiple availability domains? A. Backend set health check policies are correctly configured and healthy. B. The DNS tiering policy directs all traffic to one instance. C. The load balancer has a single subnet with no redundancy. D. Security lists allow unrestricted inbound traffic from all its. Answer. Correct answer. A. Explanation. Load balancers rely on back-end health checks to determine which instances are healthy and eligible to receive traffic, ensuring proper distribution and failover. DNS steering policies control traffic at the domain level, not load balancer back-end distribution. Using a single subnet with no redundancy reduces availability and is not recommended. Security lists should be restrictive, not unrestricted, to maintain security while allowing necessary traffic. Correct health check configuration is vital for load balancer reliability. Question 20. One might argue that the most effective way to enforce organization-wide encryption standards for OSI storage services is to A. Implement IAM policies that require encryption for all new storage resources. B. Rely on default service encryption settings without policy enforcement. C. Use manual encryption configuration on each resource individually. D. Delegate encryption responsibility solely to application developers. Answer. Correct answer. B. Explanation. Default encryption is enabled for most OSI storage services, but relying solely on defaults without policy enforcement can lead to inconsistencies and gaps in compliance. IAM policies allow administrators to enforce encryption requirements organization-wide, ensuring no unencrypted resources are created. Manual encryption per resource is error-prone and not scalable. Delegating responsibility only to developers risks inconsistent implementation. Therefore, IAM policy enforcement combined with defaults offers the most effective standardization. Question 21. Within the framework of OSI compute management, LoRa needs to ensure that her VM instance is moved to a different fault domain without downtime. What OSI feature should LoRa use to accomplish this? A. Stop and restart the instance in the target fault domain. B. Use live migration feature to move the instance. C. Create a new instance in the desired fault domain and migrate data manually. D. Change the fault domain in the instance details through the console. Answer. Correct answer. B. Explanation. OSI's live migration allows the movement of running instances to different fault domain without downtime, maintaining service availability. Stopping and restarting causes downtime. Creating new instances and manual migration is labor-intensive and not seamless. Changing fault domain via the console is not permitted after instance creation. Live migration is designed to improve fault tolerance and operate flexibility in OSI environments. Question 22. Based on the information, Thomas wants to limit resource creation within a compartment to avoid exceeding budgetary constraints. Which OSI feature best helps them enforce hard limits on resource usage? A. Compartment quotas. B. Tagging policies. C. Budget alerts. D. IAM policies. Answer. Correct answer. C. Explanation. Budget alerts notify users when spending approaches or exceeds predefined thresholds but do not prevent resource creation. Compartment quotas set hard resource limits, preventing further provisioning once reached. Tagging helps classify resources but does not enforce limits. IAM policies control access but do not manage resource quotas. Thus, compartment quotas are the most effective method to enforce resource limits and avoid budget overruns. Question 23. In the context of OSI networking, Nina must design a solution to allow private instances in her VCN to access OSI public services without traversing the internet. What OSI component facilitates this? A. Service gateway. B. Internet gateway. C. NAT gateway. D. Dynamic routing gateway. Answer. Correct answer. D. Explanation. Service gateway provides private access to Oracle public services like object storage from instances without using the internet, preserving security and reducing latency. Internet gateway routes public internet traffic. NAT gateway allows private subnet instances to access the internet but does not provide private access to Oracle services. Dynamic routing gateway connects the VCN to on-premises networks through other VCNs but does not facilitate access to Oracle public services. Therefore, service gateway is the correct choice. Question 24. Taking into account the evidence, Emma wants to automate notifications when specific OSI compute metrics exceed thresholds. Which service combination should she use? A. OSI monitoring service and alarms. B. OSI Vault and IAM policies. C. OSI Resource Manager and Terraform. D. OSI Client Shell Scripting. Answer. Correct answer. A. Explanation. OSI monitoring collects resource metrics and alarms trigger notifications when metric thresholds are breached, enabling real-time alerts. Vault and IAM manage security, not monitoring. Resource Manager and Terraform automate infrastructure provisioning but do not handle runtime alerting. OSI client and shell scripting can automate tasks but lack native alerting features. Hence, monitoring with alarms is the optimal choice for metric-based notifications. Question 25. From a practical standpoint, when deploying an OSI load balancer for high availability, which design principle must Sophia follow? A. Distribute backend instances across multiple availability domains. B. Place all backend instances in the same subnet and availability domain. C. Disable health checks to improve performance. D. Assign a public IP to each backend instance. Answer. Correct answer. B. Explanation. Distributing backend instances across multiple availability domains enhances fault tolerance and availability, a best practice for load balancer deployments. Placing all instances in a single domain reduces resilience. Health checks are critical for detecting unhealthy instances and must remain enabled. Assigning public IPs to backend instances is unnecessary and reduces security. Backend instances are private, therefore multi-domain distribution with health checks enabled is essential. Question 26. According to recent studies, Mark implements OSI object storage lifecycle rules to manage data cost-effectively. Which of the following best explains how lifecycle policies optimize storage costs? A. Automatically transition and frequently accessed data to archive storage. B. Immediately delete all old data to save space. C. Require manual migration of data to cheaper storage tiers. D. Encrypt data to reduce storage costs. Answer. Correct answer. C. Explanation. Lifecycle policies automate the transition of data to cost-effective storage tiers like archive storage, helping optimize costs based on data usage patterns. Immediate deletion risks data loss. Manual migration defeats the purpose of automation. Encryption secures data but doesn't inherently reduce storage costs. Automating tier transitions based on access frequency ensures cost efficiency and compliance with data retention policies. Question 27. Given the circumstances, Alice uses OSI Vault to store encryption keys. What is the best security benefit she gains by using Vault over storing keys in instance metadata? A. Vault provides centralized key management with auditing and controlled access. B. Keys in metadata are automatically rotated by OSI. C. Vault eliminates the need for encryption in OSI services. D. Instance metadata provides better encryption performance. Answer. Correct answer. A. Explanation. OSI Vault centralizes key management, enabling secure storage, access controls, key rotation, and auditing, reducing risks of key compromise. Keys stored in instance metadata lack centralized management, are less secure, and pose exposure risks. Vault does not eliminate encryption needs. It supports encryption. Metadata does not impact encryption performance. Centralized vault management is a security best practice for sensitive key handling. Question 20. In a scenario where Paul needs to manage multiple OSI environments programmatically with scripting, which OSI tool should he prefer for consistency and automation? A. OSI CLI. B. Console dashboard. C. Load balancer. D. Security list. Answer. Correct answer. D. Explanation. OSI CLI is the command line interface designed for scripting and automation across OSI resources, providing consistency and control. The console dashboard is a GUI not suited for automation. Load balancer and security list are OSI resources, not tools for environment management. Hence, OSI CLI is the appropriate tool for scripting and automating cloud operations efficiently. Question 29. While examining the implications of compartment design, Sophia wants to minimize the blast radius of security incidents. Which approach aligns best with OSI best practices? A. Use multiple compartments to isolate resources by project or team. B. Consolidate all resources into a single compartment for simplicity. C. Disable IAM policies for broad access. D. Assign all users to the admin group. Answer. Correct answer. A. Explanation. Multiple compartments enable isolation of resources and granular access control, limiting impact of security incidents. Consolidating resources in a single compartment increases risk exposure. Disabling EM policies removes access controls, compromising security. Assigning all users admin rights violates least privilege principles. Proper compartment design is a cornerstone of OSI security practices. Question 30. The core principle of OSI monitoring service is to a. Collect, query, and visualize metrics for OSI resources. B. Automatically provision new compute instances. C. Store encryption keys securely. D. Provide a graphical user interface for billing reports. Answer. Correct answer. A. Explanation. OSI monitoring collects metrics from resources, enabling users to query and visualize performance data for troubleshooting and capacity planning. Provisioning instances is done via OSI Compute or Resource Manager, not monitoring. Key storage is the role of OSI Vault. Billing reports are handled through cost analysis dashboards. Monitoring is essential for maintaining resource health and operational insight.